Hey guys, we're going to start chapter 7 today, and we're going to start obviously with section 7.1. All right, and in this chapter, we're going to be discussing area, surface area, and volume. All right, if I had a piece of toast and I cut it on the diagonal, all right, and I cut it into two triangles, I could rearrange those two triangles and I could make a bigger triangle. I could match them up differently and I could make a parallelogram. When I do that, did that change the amount of toast that I started off with? No, I still have my two pieces, my two triangles that I cut originally. I just turned them different ways and made these different shapes. So only the shape changed. In the next few lessons, you will learn how to rearrange a shape to make a shape for which we already know the area formula. Here we have a parallelogram. Remember, a parallelogram is similar to a rectangle, but it's on a slant. And if I were to keep the same exact dimensions, but turn it differently, as I am right here, it doesn't matter how it's turned, it still takes up the same amount of space or the same area. So just like the amount of toast did not change, neither will the area of this shape. Now, when finding area, there's several things that I really think are important for us to remember. One, obviously, we need to know our formulas. So you might want to start yourself a set of flashcards or just commit these to memory. But you do need to know that the area of a parallelogram is base times height. That's extremely important. You also need to know that any side can be a base. So don't limit yourself to thinking it's always going to be the one that's on the bottom. That's not necessarily true. Any side can be a base. The height is always going to be perpendicular to one of the bases. All right? So the height is always perpendicular, and perpendicular, when we think of perpendicular, if this is my base, it will be running this way. It will always form a right angle. So the height is the perpendicular distance from a base to the opposite side. Area is always in square units. And we can write square units as either whatever the unit is squared, or we can just write SQ in the name of the unit. So if it's inches squared, then we can do this. If it's meters squared, we can do this. All right, so the units squared. We are going to also treat all of the letters in our formula as variables. So B and H will now become variables. And this is going to really help us later on when we go to solve for a missing dimension. We can treat it just like we would an algebra problem, and we can solve to find the missing dimension. So B and H are now going to be considered variables. Another thing I want you to remember when we're solving equations is, number one, we will always start with the formula. Even if you think you know it really well, always start with the formula. Then we will replace the variables in the formula with the values given. We will solve and label with correct square units. So let's try it with this one, with this parallelogram. All right, we already said that our formula is A equals B times H. So now I'm going to replace my variables with the values given. All right, so I'm going to have A equals, my base is 20 and my height is 25. Now, when I have variables side by side and no operation, what operation is always going to be done? We're going to multiply, that's right. And it's when you have two numbers, you have to separate them somehow. So either with a set of parentheses or with a dot. All right? And so it doesn't become confusing. And when you multiply 20 times 25, you're going to get 500 Our measurement is in meters, and they will always be square units. So our answer is A equals 500 meters squared. All right, now let's try solving these together. All right, so here we have another parallelogram. Notice how they had to come up with our height. All right, and let's start off with A equals B times H. That's our formula. We don't know the area, that's what we're solving for, but we do know the base is 7, and we know the height is 18. So now we're going to multiply 7 times 18, and A is equal to 126. My unit is inches, and they, of course, will be squared. All right, let's do the same thing for this one. Let's write our formula. A equals B times H. We are solving for area. My base is 30. My height is 20.5. I'm going to now multiply those two numbers together. Don't forget, you have a decimal. Make sure you include that in your answer. Go ahead, multiply. Did everyone get 615? And then our unit of measure is yards squared. All right. Now, sometimes because they want to challenge us and make us think, they're going to give you a shape that maybe is measured in yards, but they want you to give the answer in feet. So we know how to use a conversion factor. We learned that a while back in a few chapters previous to this. So we're going to be using a conversion factor to find our answer. All right, so if we were converting 1 yard to feet, we would say 1 yard squared is, because I would multiply 1 times 1. 1 yard squared would give me the area of this shape. And I know that's the same thing as saying 1 yard times 1 yard. That's what 1 yard squared means. So now if I'm going to convert it to feet, I'm going to say, well, there are 3 feet in 1 yard. So now it will be 3 feet times 3 feet, which equals 9 feet squared. So you can use a similar procedure to convert other square units. All right, when I look at this parallelogram, what I'm going to do though is I'm going to find the area of the shape in meters, and then I will convert them. So I'm going to say with my formula, A equals B times H. A equals 4, remember any side can be a base, times 10. And I'm going to get 40 meters squared. Now they want this though answered in square centimeters. So I'm now going to convert my 40 meters to centimeters. And I'm going to use a conversion factor to do that. All right, so let's go ahead and write down what our conversion factor is. I'm going to find what 1 meter squared would be. So I'm going to come up here and I'm going to say 1 meter squared is equal to 1 meter times 1 meter. That's what that means, right? So now I'm going to be converting my meters to centimeters. And we should know that there are 100 centimeters in each meter. So now I have 100 centimeters times 100 centimeters. And that's going to give me 10,000 centimeters squared. Remember, find your basic fact. 1 times 1 is 1. Count up the number of zeros. I have 4 zeros in my equation. I will have 4 zeros in my answer. So my answer is 10,000 centimeters squared. That's my answer to my conversion factor. So now I'm going to plug that in to my 40 meters. So I'm going to come over and I'm going to say 40 meters squared equals 40 meters squared times my 10,000 centimeters squared over my 1 meter squared. All right, I'm now going to, because these can now cancel out, I can simplify. I now have 40 times 10,000 centimeters squared, because 10,000 over 1 is equal to 10,000. And when I multiply that together, 40 times 10,000, what am I going to get? That's going to equal 400,000 centimeters squared. And that will be my answer. I have now converted 40 meters squared to 400,000 centimeters squared. All right, before we end our lesson today, I want us to find the area of a parallelogram. So I want everyone to start off with their formula. I want you to plug your numbers into your formula. And I want you to solve. Make sure your units are squared. And your final answer should be 80 feet squared. All right, class, you can look now to your assignment that will be on the portal. It will tell you what questions to answer, and you can practice more. I will be giving you my email. You can email me with questions. If you need anything at all, I am here to help you. All right, thanks, and have a great day.